Yesterday we covered what a rational expression is. It's just a fraction with variables, polynomials in it. And then we covered the domain. The domain is what makes the bottom 0. That is off limits in the domain. We also looked at an example where there was a hole in the graph. That is also off limits in the domain. So let's look at the top box. This looks very elementary, but I really liked how it was laid out. I liked how the examples were simple, more challenging. Simple, more challenging. So you kind of get a taste of what's the foundation, and then what's the appropriate grade level of what we're at. Yeah, that one has, okay, I was going to say, we won't have A as 1 every single time. We will have some where A is not 1, and that is on the back, so you'll see an example of that. Okay, simplifying. This is from yesterday. Remember to factor completely. Bless you. Factor completely, and then eliminate any common factors. Eliminate any common factors. When you eliminate common factors that have an X in them, then that's a hole in the graph. So I'm going to draw an arrow and I'm going to write hole in the graph, but I'm putting in parentheses if it has X. And then write it, and then I'll explain what I mean by that. The very first one you should be able to do on your own. So if you'll do that right now, that's not even really a polynomial. That is just a giant fraction with a bunch of multiples. You've got numbers X, Y, and Z. They're all being multiplied together. So simplify that. Refresh your memory on the rules of exponents. Okay, so if you're still simplifying, wrap it up or pause and look up here. So when I'm simplifying, I always, looking at the numbers, I think of it as just a fraction of 45 over 9. And 45 does divide by 9 how many times? So I think to myself, okay, 9 is going to go away and go into the 45 5 times. Then I look at the variables and I eliminate the one with the smaller coefficient. So I'm going to eliminate the x squared because it's going to go up here into the 3 on top and leave me with just an x. You have to be careful when you do that so that when you're writing your final answer you don't overlook it. This y to the first power is going to take the 5 down to a 4, and then now reverse direction. This z to the 1 power is going to come down here and make that a 6. Remember to think of it in expanded form to visualize what's canceling and what's left and where it's left. You should have 5x y to the 4th over z to the 6th. We're not going to talk about domain there because that's got 3 variables. Now, number 2 is exactly like the IXL from yesterday, or this morning. let's get it in factor form. You will notice that A is 1 here and here, which means we can go straight to parentheses if it will factor. The way to check if it will factor, I say multiply A times C because I want you in that mindset in case A is not a 1. So just, even though it is a 1 here, I still want you to do it. So A times C, factors of negative 16 that add up to equal 6. The 6 came from the middle term, by the way. Factors of negative 16 that add up to equal 6. 8 and 2, which one's negative? 2. There you go. And since A was 1, I can go straight to parentheses, 8 and negative 2. Of course, my letter is X. Repeat with the bottom polynomial. A times C, factors of 32 that add up to 12. 4 and 8. Right? And A is 1, so positive 4, positive 8. Order does not matter how you arranged your parentheses. Now that they're in factored form and they're separated by multiplication, think of those as like blocks. Think of it, y'all remember those wooden blocks that you used to play with as a kid? Think of it as a block that literally has written on it x plus 8. Then you have a block that says x minus 2. Then you have a block that says x plus 4. Then you have a block that says x plus 8. If you think of it that way, your mind might not go in and cancel those single terms. You know, like yesterday when you were asking that good question. Let me show you what I mean. Like, red is wrong here. Don't do that. Think of it as a block with that whole polynomial written on it, and then you won't do that, because that would be wrong. Okay, so this and this are common factors, and then I'm left with x minus 2 over x plus 4, right? Now, because that common factor had an x in its expression, that means it's a whole. So it helps to write over it to yourself like, oh, watch out, there's a hole in the graph. Because that common factor canceled. And then down here, once you get to the end, now you have to say to yourself, what's off limits with the bottom? Top doesn't matter at all. It's the bottom that matters. Remember, because we're dealing with fractions and one cannot be in the bottom. You can't have a 0 in the bottom. So to find my domain, set that equal to 0 and solve, right? And that is your off limits as well. So we have a whole. Then we have, this is an asymptote. You gotta know your asymptote from a hole in the graph. That's a Ryland joke. And I always have to say it in my head before I say it out loud so I don't mess it up. You gotta know your asymptote from a hole in the graph. They're different. An asymptote is just the bottom restriction with the denominator. A hole in the graph is when there is literally a gaping hole in your expression because you canceled something out. Now, how do you find out where the hole is? The exact same way that you find out the restriction at the bottom. You just say to yourself, what would make that 0? What would make that? Negative 8 would make that 0. You set it equal to 0 and you solve in your mind and you say there is a hole at negative 8. Does that make sense? So if I said to you to write the domain officially, you would go all real numbers, that little E, all real numbers, and a little restriction can't be negative 8 or negative 4. Is that the door? Oh,
Okay, why would we do negative 8 if they cancel out?
There's a hole in the graph. It means that when you're graphing, that negative 8, because if you think about it, if I plug negative 8 in, it doesn't matter which one you plug it in. If you plug it in, well, if you plug it in the top, you have 0, but if you plug it in the bottom, what do you get? Once again, on the bottom, you would get if I had a negative 8 right here, what would I get? I'd get a 0. And what's anything times 0? 0. And then where is this? In the bottom of the fraction, and that's the problem. It's just simplifying. Do you have a question? Yeah.
So would you be able to do like the find like the hole in the graph like before you mark out like the other stuff? Or maybe like
When you break it down to start marking stuff out is when you're going to find the hole every time. And that's why you want to break it down, because if you go from just the original problem and just focus on the denominator and set it equal to 0, you're still going to get the same numbers. You're going to get negative 8 and negative 4. But the problem is, since you didn't factor the top, you don't know which one's a whole and which one's an asymptote. And there's a big difference. In terms of the graph, y'all, a hole, I'll try to draw a graph of both. So a hole in the graph is exactly what it sounds like. And then an asymptote is, especially a vertical, these are vertical asymptotes. A vertical asymptote is where the graph will never touch, ever. It will not ever cross over. A hole, it will cross over, it's just there's a hole there. So it'll get all the way up to that number, but it'll skip right over it. But an asymptote, it will approach it, but it will never reach it, ever. And that's because at that value, you get 0 on the bottom of the fraction, and that's no bueno. So that's the difference between what it looks like in the graph. Imagine this was negative 8, and this was negative 4. That's an example of what it looks like.
So last year we were graphing those equations, but we weren't writing them.
You should have been graphing them and factoring them too, probably.
We never wrote any of that.
You didn't write the domain?
No.
Oh, okay. Then yeah, that's probably. It's been a few years since I've taught algebra 2, so I don't remember. You might have written the interval notation domain.
Yeah.
You might not have done the set notation. And if you want to do the interval notation, that's fine. I like the interval notation. Some people, for some reason, don't like it, so I always show both. So this, for the interval notation, just imagine a giant number line shaded with a hole on negative 8, negative 4. It would be this. Does have to be in order, least to greatest. So that's what it would look like for the interval. And that's where you're saying that the graph covers those x values. Okay. Now let's get to multiplying and dividing. So you might think, why are we not adding and subtracting? Well, that's harder. Adding and subtracting is more challenging. And that's because when you add and subtract fractions, you have to have a common denominator, and that is where some people panic and run. Y'all ever seen Chicken Little? You know the dodgeball scene? What's the pig's name? Can't remember his name. Anyways, you know the dodgeball scene where the pig just is like, ah! You know, okay, when I throw add and if you've not seen that, now you gotta go look at it, because now it looks stupid. But the dodgeball scene where the pig starts panicking and running is about how people feel with adding and subtracting rational expressions. So let's do multiplying and dividing first, because it's very easy. How do you do it? Well, you should probably know that this is factor completely, spell it right, if possible, and then eliminate step here that says, number 3, multiply straight, I want capital letters here, straight across. For some reason, when sometimes people see 2 fractions and they tend to impulsively cross multiply, and that is wrong. You only cross multiply if you have a fraction equals a fraction. If you will notice, there is not an equal sign anywhere on the sheet, right? Just because we don't have equations right now. We just have expressions. There's a huge difference. So when it comes down to you to multiply, you're just multiplying straight across. Top times top, bottom times bottom. So let me make a note right here. This is a proportion. This is an expression. Look at the difference. And I'm going to make it easy. 1/2 equals x over 4. 1/2 times x over 4. Look at the difference. The difference is this has an equal sign, that does not. That just says multiply. Alright, so this is what we're doing right here, expression. We are not doing a proportion right now. That's another day. We're just doing this. Okay, so look at it. You can't factor anything here, but you can look at common factors. Like this 2 on top will divide into the 8 how many times? 4 times. The 3 on the bottom will divide into the 9 how many times? 3. And there's your answer. That was too easy. Let's go to more challenging. We've got polynomial expressions and rationals. We want to get every single thing in factor form before you multiply. You do not want to try to multiply all this out because then it will not be factorable. Well, it is, but it won't be attainable. It won't be as attainable. You want to factor it when it's small. You don't want to factor it after you've multiplied. So looking at this is where you got to start recognizing what's that. That's a difference of squares right here. I'm going to say d of s, difference of squares. So that's going to be x plus 3, x minus 3, right? You square root both terms, and then one's positive, one's negative. Now look underneath it. You only have 2 terms, which is your clue that it's either GCF, difference of squares, or cube, perfect cube. What is it? GCF. What do they have in common? 5. Pull it to the front. They have 5 in common. What's left? Divide the front, up the front to the 5. Divide 5 to the front. What's left? 2x plus 1. Okay. What's this one? GCF of 2x. What's left? 2x plus 1. Alright, what's the bottom? GCF of 2x. What's left? X minus 3. Okay. Now, be careful. Don't get too excited and cancel every single thing out. There is stuff left. Obviously, 2x and 2x cancels. Because it has an x with it, that means it's a whole. Has to have an x with it. Let's say it was just 2. What if it was just 2 over 2? That's not a whole. That's just a factor. Okay? So it has to have an x in the expression. So what would make that 0 if x were 0, right? 2 times what would give me 0? 2 times 0. So there's a hole at 0. Is there another hole? X minus 3, right? So this is a hole, and it's at x equals 3. So now, nope, I'm not done, am I? What else? Yep, that goes with that. There's another hole. You may have to think a little harder here. Imagine setting it equal to 0 and solving. You would subtract the 1, then divide by the 2. You'd subtract the 1, then divide by the 2, which means 2 would be on the bottom. Okay, now I can write what's left. Across the top, read carefully, you got x plus 3. Across the bottom, you got 5. Right? Do we have any vertical asymptotes? Say no. No. That comes from your final simplified expression and then whatever would make the bottom 0. Well, since the bottom has no x, it will never be 0. It will always be 5. So no vertical asymptotes. You do have 3 holes in the graph. So if you were to write the interval notation, you would imagine the whole number line shaded, open on 3, 0, and -1/2, and you would put it in order from least to greatest, left to right. So it would be -infinity to -1/2, then -1/2 to 0, then 0 to 3, then 3 to infinity. That one's the same. Alright, so that's multiplying. We're only going to do 2 examples of multiplying because do you remember how to divide fractions? What? I heard it. Keep, change, flip. Which means, are you actually dividing fractions? No. Which is why I only did 2 multiplying problems, because now we're going to divide, which means we're still multiplying. Okay. On the back, you will factor completely, if possible. Now, I do not like how number 2 doesn't incorporate keep, change, flip. Like it's saying it, but it doesn't use it in those words. So I want you to either in the space right here or over here next to it in capital letters, I want you to put keep, and then I'm making it fancy. Change, flip, and then maybe even highlight that crap. Don't like when I call it. I know. Wait till we start dealing with discriminant. I literally call it the crap. And then I'll say, put this crap over here. Once you find that crap, it works. Okay. What does keep, change, flip mean? It means multiply instead of divide, and flip the second fraction, which is called the fancy word reciprocal. You are never, ever actually dividing fractions. You never divide fractions. It's not possible. You are actually multiplying by the reciprocal of the second fraction, which means, by the way, order matters. Order matters because whatever's listed first keeps, whatever's listed second flips. Okay? And then the last step we already know is eliminate any common factors. Because now you're multiplying. Alright, so let's start simple. You don't want to cancel until you have rewritten it in the keep, change, flip mode. Do not cancel until you have rewritten it. Okay? Alright, so keep, change, flip. Now, eliminate common factors. The 5 will go into the 20 4 times. Now multiply straight across. And that one was too easy. Let's go to grade level appropriate. Order matters. Keep. And when you keep it, go ahead and rewrite it and go ahead and start factoring if you want. So you're not writing 10 steps in one problem. So this is going to keep. I don't know if y'all want to write it out there or you want to write it here. It doesn't matter. Alright, look at the bottom. That is a difference of squares. Do y'all see it? 4 is perfect. X squared has an even exponent. It's a subtraction sign. 25 is perfect. So that will factor to remember to get the factors, you square root each term, and then one's positive and one's negative. Alright, so I kept it. Now I'm going to change it, right? Now I need to flip it. So you can either come up here and write these in factored form, then flip it, or you could, as you're flipping it, factor it. It's whatever you want to do. I'm going to, so as I'm filling this in, I'm going to fill in the top, which means I need to focus on the bottom because it's flipping, right? Okay, so A is not 1 there. So here's one of those where you're going to have to know how to factor by grouping, or I can show you the fraction method. I think you might like it. I'm going to show it to you. A times C. You got negative 20x squared. Middle term. Right? It's got to multiply to give me this, and it's got to add to give me that. 5 and 4. Now it's a sign game. 5 and 4. Which one's negative? By the way, the sign of whatever it adds to always matches the sign of the larger number. So if it's got to multiply to a negative and this is positive, then this one's the negative. Does that make sense? That's a little, not a trick, but here's what always happens. Okay, confirm. If you multiply them, do you get the top? And if you add them, do you get the bottom? Alright, here's the fraction method. Embrace it for a second because it will help you in terms of those problems that we get that take a whole page. And we do have some of those because what did you do when you walked in? When you walk in here, what did you do? Do you remember? It's 2 words. Oh no, I don't remember. You leveled up. Yeah, you leveled up. So we will have some problems that take a whole page. Here's the fraction method. I like it because it helps me to do this crap faster. I don't like it because it's literally me over here jotting notes. And some people don't do well with that. But here's how you do it. You write 2 fractions and you put, just watch, don't write it yet. You put AX on top. AX. So AX. 2x. And then you put your 2 numbers that you picked on bottom. Just the numbers. You see that? AX on top, the two numbers you picked on the bottom, and then you reduce it. This becomes what? That becomes x over -2, and that stays. That one's done. 2x plus 5. Watch. 2x plus 5. X minus 2. See how much faster that was? Now that's only the first time I've showed it to you. So if you're like, how did she just do that? I'll show you again on another problem. The fraction, this is the fraction shortcut for factoring. You write two fractions away from each other and you put AX on top of both, and then whatever numbers you got here, just the numbers, you put them on bottom. Whatever the numbers you are that you came up with, you put them on bottom. And then you reduce it if possible, and then you're done. And you read it. X minus 2, 2x plus 5, and then bam, you got your factors. Okay? Let's pretend like you didn't pay attention that this was a 1. Let's do this one. I'll show it to you in the fraction method again. Factors of -2 that add up to -1. -2 and 1, right? Alright, so I'm going to come over here. Fractions. AX. AX is 1x. You can write the 1 if you want, or you can leave it alone. It doesn't matter. What did we come up with? -2 and 1. So because A is 1, we can't go any further with this, can I? So read it. This is x minus 2 and x plus 1. Okay, so we kept it, we changed it, we flipped it, and then I showed you a shortcut in factoring. If you don't like the fraction method, then you don't have to use it. You would have to do this, you would have to do an aside. I call it an aside note of factoring that by grouping and then put it back into the problem. And that's why I teach the fraction shortcut method when we get to problems like this, because I don't want to lose you in the first step just because you had to factor when A was not 1. I want you to be able to get through that step, because now the hard part's over, right? The first step's the hardest part. The rest is canceling. So, here we go. Cancel. And I don't have room to write above it, so I'm going to come over here and write whole. Where is it? Yep. And we have another one. Here. Whole. X equals 2. And I have nothing else to cancel, so I can write my answer. Do I have any vertical asymptotes? Remember, your asymptotes are your final answer, whatever would make the bottom 0. So you have one at positive 5/2, which is 2.5. And what would make that 0? -1. So you have asymptotes at positive 5/2 and at -1. 2 wholes, 2 vertical asymptotes. This is going to come back up in, I think it's chapter 5. So you're going to appreciate me showing it to you right now, because we're going to graph them, technically next would be adding and subtracting, but I don't want to throw that at you and start the pig running. What would you prefer? I ran this nice little worksheet with 16 problems. It's simplify, multiply, divide. Air quotes, divide. Or, now here's the problem. Now I could post the answers. I could post the answer, the final answer, so then you know if you got it right or not. Or would you rather in iExcel and just try to get to like a 60 or a 70? Because then you know you're getting it right along the way as well. What do you? Paper, iExcel, paper. It's okay. Okay. I'm gonna post the answers, not the work, just the final answer. And you're not writing domain on here. You need to be trained. I mean, you should be good with domain now, but you're not actually writing the interval notation out at the end. This is just, can you multiply, divide, or simplify? Okay. The first 6 are just simplifying. Yeah.
Was that Grace? Why didn't you let
I ran out of room, and there's 4. There's going to be, so it would be messy. And when we get like all of our domain problems, they're not going to be that complicated. There's usually 1, 2, or 3 critical points, not 4. Because if there's 4 critical points, then there's 5 shaded sections. If you think about it. So you can write the domain there if you want to, but just the fact that you're telling me that there's a hole here and that there's asymptotes here tells me you know the domain.